If we still have wedges or dashes, the wedges and dashes still always go on the convex side of the molecule, never the concave side of the molecule. While line angle structures are fast to draw and relatively easy to learn what they mean, there are a couple of line angle structure drawing conventions that you have to know to be the best OChemNinja. I'm going to show you the top 10 today. The first convention has to do with three-dimensionality. Molecules are three-dimensional, and we depict that three-dimensionality with wedges and dashes. The wedge is implied to show that this group is coming toward you as the viewer. It's sticking out of the plane of the board toward you as the viewer. A dash is implied to show that the group is going away from you as the viewer. It's sticking into the plane of the board. So if we had a hydrogen on the end of this dash, that hydrogen would be behind your paper, behind the plane of the board. Second point you need to know is that the line angle structures depict the three-dimensional geometry of the structure as well. For that end, all of our groups on the molecule always go on the convex side of the molecule. Do you remember convex, concave? We never draw groups coming off of the concave side of the molecule. Proper three-dimensionality has all of the groups on the convex side of the molecule. So all branching groups, all wedges and dashes will always go on the convex side of the molecule. Whether that's in the northern or southern hemisphere doesn't matter. Always the convex, never the concave side of the molecule. Number 3. The wedge or the dash can either go on the left or the right side of each other. There's no preference for one over the other. So you could have the wedge on the left and the dash on the right, or the wedge on the right and the dash on the left. Either convention is just fine. In fact, if you think about what this really means, the three-dimensionality of a tetrahedron would be such that the wedge and the dash group would actually be perfectly coplanar, and the dash group would be completely hidden by the wedge group. So the fact that we even draw the wedges and dashes offset like this is a bit of a perspective drawing as well. We're really kind of tilting our perspective just a little bit, so we're really looking at it a little bit from the left or a little bit from the right. Otherwise, we would never be able to see the dash group. So whether the wedge or the dash is on the right or the left, nobody really cares. Point number 4 is that you need to flip the text label if the bond is pointing to the left. What do I mean by that? If there are, say, CH3 groups at the ends of each of these bonds, and this dash bond is pointing to the right, we would write the CH3 group as normal. But when the wedge is pointed to the left, we need to flip that label and write H3C instead, which leads directly into the next point, which is a huge pet peeve of mine. Bonds point precisely to the atom to which they are attached. So, for example, if we have the CH3 group, again, we can write the CH3 group as normal. There's nothing that changes here. The CH3 group can be written as normal. But again, if that group is bonded to the left side of the molecule, we need to flip the label. We do not write CH3. This is no good. This implies that the bond is directly attached to the hydrogens. It's not attached to the hydrogens, it's attached to the carbon. We need to be very precise. If the bond is pointed to the left, we flip the label. Another thing that I see is if there's only one bond on the atom, only one wedge, you don't have to draw the dash. If there's not a dash drawn, it's assumed to be a dashed hydrogen. Hydrogens can be implied in line angle structures. But whenever there's just one bond drawn, we do not center the label on the bond. Stop doing that. Do not center the label on the bond. The bond points precisely to the atom to which is it attached. This bond is attached to a carbon atom, then we can write the CH3 group. This works for carbon and heteroatoms as well. If we have an OH group on the end of this molecule, we would not write OH. That would be implying that this bond is directly attached to the hydrogen. It's not attached to the hydrogen, it's attached to the oxygen. We would flip the label and write OH so that the bond is directly pointed to the atom to which it is attached. Number 6, the zigzag backbone of the molecule does not have to be horizontal. The zigzag backbone could be vertical, could be up diagonally, can twist all around, it doesn't matter. Whatever is in the plane is written in this regular weighted bond. But if we still have wedges or dashes, the wedges and dashes still always go on the convex side of the molecule, never the concave side of the molecule. 7. The end of a wedge or a dash is the carbon atom. This is important when you have a wedge or a dash group that is more than one carbon long. If it's just a CH3 group, we could just leave it as the end of the stick, or we can write the CH3, that's fine. But if there's more than one carbon, then what we would do is we would draw the wedge and the dash, and what I see students do all the time, and this makes me crazy, is that they'll then extend it before diverting the chain. This does not show 2 carbons. This shows 1, 2, 3 carbon atoms. The end of the wedge is the carbon. So if you want to show a 2-carbon chain, the way that you would do that is you would draw your wedge. The end of the wedge is the carbon atom, and then you would sprout off the second carbon. This shows a 2-carbon chain sprouting off of this molecule. The end of the wedge is the carbon atom. Same thing with the dash. The end of the dash is the carbon atom. Number 8, the hydrogen atoms can be implied in line angle structures. Every one of these structures has implied hydrogens. But the hydrogen must be explicitly drawn when C is explicitly drawn. If the carbon is explicitly drawn, you have to write in all of its hydrogen. Or if the hydrogen is attached to a heteroatom. A heteroatom is any atom that's not carbon or hydrogen, so oxygen, nitrogen, sulfur, things like that. If you have a heteroatom in the molecule and you have a hydrogen on that heteroatom, the hydrogen may not be implied and must be explicitly drawn in every time. Or when you're drawing an aldehyde. Now, this one, the hydrogen, I guess, really can be implied. But I don't like it. I think it looks weird. This is an aldehyde functional group. It is a carbon-oxygen double bond where one side is another carbon atom and the other side is a hydrogen atom. There's a hydrogen implied there, but by convention, we typically tend to draw that hydrogen in just to make sure the reader knows there really is a hydrogen there. I just didn't forget to draw the rest of the molecule. Number 9. Lone pairs can be implied in line angle structures. You're welcome to draw them in if it helps you describe what you're trying to draw. If it helps you draw a mechanism, you're always welcome to draw in lone pairs, but lone pairs can be implied. So I've had heteroatoms here that had lone pairs that I've not drawn in. That's okay. They can be implied. If I wanted to, though, I could write in the lone pairs. Finally, you may never draw a wedge or a dash on an sp2 hybridized carbon, not unless you're getting into some pretty high ninja levels. For most purposes, though, if you have an sp2 hybridized atom, just don't draw a wedge or a dash. Why not? You may not draw a wedge or a dash on an sp2 hybridized atom. Recall, an sp2 hybridized atom is a flat trigonal planar geometry. If it's flat trigonal planar, you can't have something going in or out of the plane. Everything's in the same plane. That's what it means to be flat and trigonal planar. So if you have an sp2 hybridized atom, you must draw all of the groups on regular in the plane bonds because they are in the plane. It's a planar molecule. Everything is in the same plane. No wedges or dashes on sp2 hybridized atoms. So this is your top 10 list for line angle structure conventions. Most of these will become second nature as you get better at these over time, but when you're just learning, some of these things are not readily obvious, so it's good to have a top 10 list to make sure you're up to date with all of the latest conventions for line angle structures.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.